All right, here's our first opportunity at trying to flip the classroom. So your goal or your task is going to be to take notes on 7A as you watch the video. So our goal number 1 is to investigate direct, inverse, and joint variation. So let's start off by graphing the following points. So we're going to graph -6, -3, -2, -1, 2, 1, 4, 2, and 6, +3. All right, let's connect these and see that we have a line that goes through the origin. This line is known as direct variation because it passes through the origin. The family of direct variation graphs consists of lines that pass through the origin. All right, let's investigate this a little more because we want to get an equation of that line. Let's make a ratio of y over x. So y over x, -3 over -6 gives me +1/2. -1 over -2 is +1/2. 1 over 2, +1/2. There's a theme going here. 2 over 4, 1/2. And 3 over 6, 1/2. Notice these all have the same ratio. The value of this, we're going to call this the variable a, is 1/2. It's called the constant of variation. We're going to use this to write the equation of our line. Now, a is used, also the variable k is used to represent the constant of variation. It's just a variable. We could call it anything we want to, but those are the typical ones that are used in textbooks. So now in this case, it's our slope, so the equation of our line here is y equals 1/2 x. That's the equation for the direct variation of this particular graph. All right, let's move on. All right, let's graph some points again. So we got 1, 6, 2, 3, 3, 2, and 6, 1. All right, let's connect those. Notice we don't have a line anymore. This is a curve. And notice here, as x increases, the y values are decreasing. This relationship is known as an inverse variation. All right, we're going to come up with an equation of this also. Inverse variation. Now let's see if what we notice. Let's multiply x times y. All right, multiply x times y. So 1 times 6 is 6. 2 times 3 is 6. 3 times 2 is 6. And 6 times 1 is 6. So here again, notice we're getting the same product each time. All right, so this means this our value a, or k, all right, it's still the constant of variation, that's equal to 6. All right, so let's get an equation for this. Let's get an equation for this curve. So we have x times y is equal to 6, an equation we want to solve for y, so that means y is equal to 6 over x. That's the equation of that curve for the inverse variation. So your job is going to be to memorize the equation for a direct variation and for an inverse variation. So for a direct variation, something you covered in Algebra 1, all right, it's going to be word problems. So the words you're looking for example, x and y vary directly, or y varies directly with x. If you see that wording, you're going to connect that to the equation y equals ax. Inverse variation, you're looking for the wording x and y vary inversely, or y varies inversely with x. If you see those words, then you can either use x times y equals a, or y equals a over x. All right, two forms of the same equation. I typically use this one, y is equal to a over x. Because that's like inverse means it kind of, to me, that means it goes on the bottom. The x variable is going to go on the bottom. All right, let's look at a couple of examples, what you're going to be expecting in type of work you're going to have to do with this. So here's our first word problem. All right, as I read this, I'm going to underline the keywords because that's going to tell me how to translate this. So it says the number N of photos your digital camera can store varies inversely. So when I see the word inversely, what should pop into your head is this formula. We're just going to write it in terms of our problem, though, with the average size S in megapixels of the photos. All right, so let's set that up first. So instead of Y, we're using N. So N is equal to A over, and instead of X, we're using in terms of our problem, we're using S. Instead of X, we're using S. So our first goal, we want to write a model that gives N as a function of S. We need to find A. That's our first job. Find our constant of variation. All right, so our problem goes on to tell us some more information that we're going to need to find our A value. Your digital camera can store 54 photos. So 54 is equal to A over when the average photo size is 1.92 megapixels. All right, let's solve for A. So A is going to equal to 54 times 1.92. All right, grab your calculator. So that means our constant of variation is 103.68. All right, we're still not done with this part A yet. We have to write the model. So now we've found the A value. So our model now, we're going to take this A value, take this number, and we're going to plug it back in my original equation. So N is equal to 103.68 over S. That's your model. So all of these type of questions have pretty much three parts. You have to find the constant of variation, write the model, and then use the model to make a prediction about some other values. All right, so now let's look at part B. How many photos can your camera store when the average photo size is 3.87 megapixels? So now we're going to take the model that we just did, and we're going to plug in for S, we're going to plug in that 3.87, and solve for N. All right, use your calculators. So we're going to get 26.7. We really can't have 0.7 of a picture, so we're going to be able to store approximately 26 pictures. So this same process we're going to be using throughout these word problems. Pick the keyword, write the equation, find your constant, rewrite the model, and then make predictions about further events. All right, let's look at another example. All right, when a quantity varies directly with a product of two or more other quantities, and this is called joint variation. All right, so here again, that A is our constant of variation, but this time instead of having just one variable, we vary with more. So joint variation. It doesn't have to be two, it can be two or more. All right, so you're looking for the words Z varies jointly with X and Y. All right, example time. So if A varies jointly, there's my keyword, as B cubed and C. Okay, so let's write that. So now I'm going to use, because I'm using A as part of my formula, I'm going to use K as my constant of variation. So don't forget about that K. Varies jointly as B cubed and C. So I need to find K. All right, let's plug in what they tell us. They have to tell us enough information. I'm going to solve this for K. So that means K is equal to A over B cubed C. And plug and chug and find until I find K. So K is equal to 36 over 4 cubed times 6, which gives me, get your calculators again, I'm getting 3 over 32. Let's leave it as a fraction because we don't want to round it decimal. Let's leave it as a fraction. So our model is a is equal to 3 over 32 b cubed c. That's your model. So that now you've answered part A. All right, let's use our model to make a prediction about further events. So let's plug and chug. A is equal to 3 over 32. They're telling us that b now is 2, don't forget to cube it, times c. All right, calculator time. Put that all in the calculator. I got 21 halves, which is 10 and a half or 10.5. Like I said, decimal, fraction, mixed number, they're all valid answers. All right, let's practice a few more. Just translating. So write the equation in the given relationship. Be sure to include A or K, whatever you prefer, constant of variation. So it says y varies inversely with x. So that is y is equal to A over x. All right, z varies jointly with x, y, and r. So that is y is equal to, I'm sorry, not a y, it's a z. Got y happy here. Z is equal to my constant times x times y times r. Here again, you can use k instead of a. All right. Number 3, y varies inversely with the square of x. All right, inversely, y is equal to a over x squared. All right, you try number 4. I'll give you a moment. Try number 4 before I do it. All right, here's now, let's see, we're going to vary directly with y and inversely with x. So z is equal to our constant directly, so that's on the same line, and inversely, got that variable wrong again. Let's go back. Try that again. Directly with y and inversely with x. So directly are on the same line, inverse on the denominator. All right, try number 5. All right, let's go. So x varies jointly with t and r and inversely with s. So x is equal here, and still need that constant, t times r over s. It's all about knowing what those words mean. Inversely, directly, and joint. Understanding those relationships. All right, now you should be able to, you can start on a little bit on 7b, but that's half of 7b's homework is dealing with these 3 relationships. All right, second part of our notes here. Goal number 2. Those are just the same answers again. We're going to be graphing rational functions. All right, so first of all, what's a rational function? Rational means fraction. So that's going to be the quotient of 2 polynomials. So a function of the form f of x equals p of x over q of x. Now remember, denominator can't be 0, so that's why we have that restriction. Q of x cannot equal 0. We're not going to be able to ever divide by 0. All right, so we're now going to have a new parent graph. We'll add to our list. Let me move this out of the way. This is called the reciprocal function. So it's like my f of x is 1 and my p of x is x. So it's a fraction. All right, parent points. So let's use our -2, -1, -1 half, 0, 1 half, 1, and 2. All right, substitute in for x. So this will be 1 over -2, which is -1 half, 1 over -1, which is -1, 1 over -1 half, which is -2. All right, 1 over 0 is undefined, so it's not going to have a y value. 1 over 1 half is 2. 1 over 1 is 1, and 1 over 2 is 1/2. All right, let's graph this, and then we'll answer those questions on the right. All right, so we have -2, -1/2, -1, -1, -1/2, -2. All right, so what this graph does, because x and y can't equal 0, these are, remember, the asymptotes we talked about at the beginning of the school year? This is going to have asymptotes. The x-axis is going to be a horizontal asymptote, and the y-axis is going to be a vertical asymptote. So that's half of our graph. All right, let's graph this through the positive half now. So we're going to have 1/2, 2, 1, 1, 2, 1/2. So here again, we got to respect those asymptotes. So it's coming in looking like that. It's never going to cross the x and the y-axis. It gets really, really close, but never crosses it. All right, so let's look at the bullets at the bottom. F of x equals 1 over x decreases on the intervals. Notice that these are both pieces of this is decreasing. So it increases on decreases. There are decreasing intervals. We always answer in terms of the x's. So -infinity to 0, 0 to infinity. Because they're both decreasing. This is a roller coaster. We're going downhill on both of our pieces. We're said to be, because there's a break in our graph, we're said to be discontinuous at x equals 0. The y-axis is a vertical asymptote, and the x-axis is a horizontal asymptote. All right, this is said to be an odd function because it's symmetric with respect to the origin. It's like rotational symmetry. If we rotate this about the origin, pieces are going to match up. So think about rotational symmetry from geometry. All right, let's go talk about domain and range. All right, we can't have 0 in the denominator. So that means our domain is all reals, but x cannot equal 0. So since x can't equal 0, y can't equal 0, so our range is all reals, but y cannot equal 0. We have a vertical asymptote at y equals 0, and a horizontal asymptote at x equals 0. Oh, got that backwards. Try that again. Rewind. We got a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. Vertical asymptotes are always x equals. Horizontal asymptotes are always y equals. All right, so that's the parent graph. So now what we're going to do is we're going to look at the general form, and we're going to AH and K, just like we've done with all the graphs before. We're going to deal with AH and K. All right. All right, let's look at our first one. All right, so we have used the parent graph to sketch a graph of the following. The general form of a rational function is f of x equals a over x minus h plus k. All right. Your vertical asymptote, I'm going to use VA for vertical asymptote, is going to be given by the 0 of that denominator. So think about setting x minus h equals 0. So x equals h is going to be the vertical asymptote. And the horizontal asymptote is going to be y equals k when it's in general form. All right, so remember, h slides the graph left and right, k slides the graph up and down, and a is going to stretch it. All right, so let's look at our first one. In this case, this is our a. So our a is -2. All right, so like we've done all our other graphs, we're going to start off with those parent points. -2, -1, -1/2, 0, 1/2, 1, and 2. All right, so we're going to have -1/2, -1, negative 2, undefined, 2, 1, and 1/2. So we're going to be multiplying those parent points times negative 2. So we're going to have positive 1, positive 2, positive 4, nothing, negative 4, negative 2, and negative 1. So we're still counting from the origin because we haven't moved this left or right. So we're still counting from the origin. All right, let's graph it. Negative 2, 1, negative 1, 2, negative 1/2, 1, 2, 3, 4. All right, still going to have our x and y axes are our asymptotes. All right, 1/2 negative 4, 1 negative 2, 2 negative 1. So here's our second piece of our graph. All right, so in this case, our vertical asymptote is x equals 0, and our horizontal asymptote is y equals 0. All right, domain, all reals, but x cannot equal 0, and our range is all reals, y cannot equal 0. All right, let's do a couple more of these to make sure you got this. All right, this one's changed a little bit. So here, my h is equal to 3, my k is equal to 2. So that means I got a vertical asymptote at x equals 3 and a horizontal asymptote at y equals 2. All right, dot in your asymptotes first and put dotted lines to represent your asymptote because technically they're invisible lines, okay? So x equals 3, here's an asymptote. Y equals 2. All right, our A is 1, so that's not going to change. I'm going to stretch it any. Now we're going to start counting. This is going to be my counting point now. I'm going to start counting from this value. So when I'm still going to use those parent points, but I've moved my origin. It's not really a vertex, okay? It's a move where I'm going to count from. All right, so I'm back to those counting points, same counting points again. Negative 2, negative 1, negative 1/2, 0, 1/2, 1, and 2. All right, so I've got negative 1/2, negative 1, negative 2, nothing, not 0, nothing. All right, 2, 1, and 1/2. All right, now so I'm just counting. I'm counting from that red dot that I did. Okay, so I'm going to go negative 2, negative 1/2, negative 1, negative 1, negative 1/2, negative 2. All right, so now I'm going to respect those asymptotes. All right, 1/2, 2. It's going in from here, 1/2, 2, 1, 1, and 2, 1/2. So here's the second half of my graph. All right, so there's my graph. So here again, my domain this time is all reals, but x cannot equal 3. And my range is all reals, but y cannot equal 2. All right. Now we can also find the x and y intercepts here. All right. So it takes a little bit of algebra to do that. Let's do this with this example, our x and y intercepts. All right. So I want to know my x-intercept. So when y equals 0? So let's plug in 0 and solve for x. Because it's not a whole point here. We can't read it from our graph. Alright, so I'm solving for x. So I'm going to move the 2. Equals 1 over x minus 3. Think about it as cross multiplying this. So this becomes negative 2 times x minus 3 equals 1. Distribute my negative 2. And I'm solving for x. Subtract 6 and get negative 5. Divide by 2 and get positive 5 halves. So that means my x-intercept is 5 halves 0. Alright, find the y-intercept. That's when x equals 0. So let's solve for y when x equals 0. So 1 over 0 minus 3 plus 2. So y equals negative 1/3 plus 2, which is equal to 1 2/3 or 5/3. So 0 5/3 is my y-intercept. Alright, take a moment and look at that. Make sure you got that. So that was just like Algebra 1. Just got some fractions in there. Alright, a couple more. Alright, let's look at this one. How's this moving? Let's see. H is equal to negative 1. K is equal to negative 2. And A is still just 1. Alright, so that means I have a vertical asymptote at x equals negative 1. A horizontal asymptote at y equals negative 2. I'm going to dot those in first. Always draw your asymptotes first. So dot in at negative 1. Y equals, negative 2. Almost made a mistake there. Alright. Let's get rid of that little errant mark. Alright, here again, parent points. Always come back to those parent points, just like we did before. Alright, negative 2, negative 1, negative 1/2, 0, 1/2, 1, and 2. So negative 1/2, negative 1, negative 2, nothing, 2, 1, and 1/2. Alright, here again, my new counting point is this, for the intersection of my two asymptotes. Alright, so let's do the negative half. So go to left 2, down 1/2, left 1, down 1, left 1/2, down negative 2. Alright, going to respect those asymptotes. We're not going to cross those asymptotes. Alright, positive half. I'm going to go right 1/2, up 2, right 1, up 1, right 2, up 1/2. Alright, so we got those. So there's our graph. These graphs have two pieces right now. Alright, one more. Okay, what do we got here? We see that H is 0, K is negative 3, and this time A is 2. Okay, so that means what? Our vertical asymptote is x equals 0. Our horizontal asymptote is y equals negative 3. Alright, always draw your asymptotes in first. So x equals 0. Alright, that's just our y-axis. You can dot that if you want to. And y equals negative 3 is our horizontal asymptote. So vertical asymptote is x equals 0. Horizontal asymptote is y equals negative 3. Alright, here we go. Parent points again. Hopefully you got memorized those by now. Write down your parent points. Alright, this time we have an A other than 1. It's 2, so we're going to multiply by 2. So multiplying by 2 becomes negative 1, negative 2, negative 4, nothing. 4, 2, and 1. All right, so we're graphing from there, counting those parent points. All right, this time we're, like I said, this is where we're counting from, not a vertex, okay? This is where we started counting from. So we're going to go left 2 down 1, left 1 down 2, left a half down 4. Respect those asymptotes. All right, positive half. We're going to go a half up 4, right 1 up 2, and right 2 up 1. There's my second piece. Respecting those asymptotes. All right, let's make sure we got domain and range. I didn't talk about that with the last one. Domain is all reals, but x cannot equal 0. Our range is all reals, but y cannot equal -3. All right, y-intercept, there's none. Doesn't touch the y-axis, but we do have an x-intercept. Let's find that x-intercept. All right, x-intercept. So that's me when y is 0. So plug in 0 for y and solve for x. 2 over x minus 3. Add 3. Cross multiply. Divide by 3. So our x-intercept is 2/3 0. All right, that's our notes. So let's see how we do. You can start on 7b, but you will be given time in class to work on 7b. But you might want to start on it and get some of them done. All right, thanks for listening, and I hope our flipped classroom works well.